Let's go through LeetCode 3219, minimum cost for cutting cake 2. For this question, it gives us an m multiplied by n cake that need to be cut into 1 to multiple by 1 pieces. So this m and n are given in the 0 to arrays, horizontal cuts, in the vertical cuts. Let's change this one to h so that because we are going to use this a lot. And the horizontal cuts of size m-1. In the horizontal cut I represent the cost to be cut along the horizontal line I. And also vertical cuts j represent the cost to cut along the vertical line j. So in one operation, you can choose any piece of cake that is not yet 1 multiplied by 1 square and perform one of the following cuts. Cut along a horizontal line at the cost of horizontal cut I, or cut along a vertical j at the cost of vj, right? So it asks, we need to get all of the cake to be 1 to 1 piece, and we need to find the minimal total cost. So for this question, we have m multiplied by n, that is 10 to the power 5th range, right? So we know like DFS plus memo maybe out of TRE for this question. So we should have some kind of linear or n log n or m log n, those kind of time complexity approach. For this question, if we observe how it is the cut is performed, we'll see it chooses the highest cost of the vertical cut in the horizontal cuts, the 5 first, right? And then the first cut is doing a vertical cut to cut 5, and then he do cut any of these two, right? And also, so what this give us some kind of hint is that we should cut the cost with which is bigger first, right? Because when we cut some, for example, those cut at initial stage, for example, the vertical cut, it is 100, it's a very big one, right? And current horizontal, it is only one horizontal piece, right? So if we cut this one, the vertical cut at the beginning, for example, this is a very high one, and then we'll see this kind of vertical cut will only be cut once, right? And also horizontal one, right? So if we have 3, right? So this one will, if we have a vertical cuts, the horizontal will increase by 1, right? And also if we have horizontal cuts, for example, if we the next approach is have a horizontal cut here, right? Then if we do a vertical cuts, for example, we have another vertical cuts. So this one will will do the V, for example, VG 3 times, right? So if there are 3 horizontal parts, 1, 2, 3, then we'll have VG to take place 3 times. So in future, what we think about is that we have the highest cost take place as early as we can, right? So we think about one approach is that we compare those kind of horizontal cuts in vertical cuts and horizontal cuts, right? So we sort them and use the 2 pointers and to compare which cost is greater. Then we move which pointer, right? But we need to prove the correctness for this, right? So to prove this one, this kind of approach, prove that choose the greater H I or VJ, right? Every time for IJ pointer. So to prove the correctness of this is that we can do the mathematical induction, right? So for example, if there is the initial cut, right? It is we have an whatever H0 and V0, right? So in this case, it's just one multiple. It is just one vertical piece and one horizontal piece, right? So if horizontal is greater, then if we take a horizontal first, then we'll have a horizontal 0 plus 2 vertical 0, right? And if we have the vertical is greater, we'll have V0 plus 2 H0. So this will be smaller, right? So we'll say at the base case, we'll choose the higher one, right? To cut. So if we already have a cut, for example, horizontal I and a vertical J, right? And for example, we assume after horizontal I cut and a vertical J cuts, right? We have A horizontal parts and B vertical parts. Now, so assume that for this kind of scenario, it is still correctness that from 0 to I, it is if it is horizontal is higher, we'll cut horizontal first, and if vertical is higher, then cut vertical. So for the I plus 1 and J plus 1, right? So to minimize our cost is that we also compare Vi plus 1 and J plus 1, right? So assume the previous cost is cost, right? So now if our horizontal is greater, right? So if we cut horizontal first, that is plus horizontal plus 1, right? And for the plus B multiplied by, right? So if we already have A horizontal parts and B vertical parts, so that B multiplied by horizontal I plus 1. And then we have vertical cuts, that is plus A plus 1, right? VJ plus 1, right? So that means that is our cost, right? And if we do the vertical cut first, that is at our I plus 1, J plus 1 cost is cost plus A multiplied by V J plus 1 and plus B plus 1, right? Multiplied by H plus I plus 1, right? So we'll say if horizontal is greater, right? This formula will be smaller. If vertical is greater, then this formula will be smaller, right? So to minimize our cost, that is, if for I and J's, HI and J, that is our greedy strategy is correct. We can induct to HI plus 1, VJ plus 1 is the correctness of this, right? So we always choose the higher one to cut, and then smaller cost, right? And also we can see if HI plus 1 and J plus 1, the cost is the same. We do horizontal or vertical either one. First, we'll have a same result, right? Because these are equal. So we use a mathematical induction to prove that the correctness, that is for every I pointer and J pointer, if horizontal cost is greater, and then we cut horizontal. If vertical cost is greater, then we move the J pointer, right? So then what we can write code, right? So we can sort those kind of cuts arrays, right? And use the 2 pointers to move, and from I is equals to the m minus 2, right? This is m minus 2, or you can see use the h dot s minus 1. And then we'll have arrays dot weight, right? So we're going to int r equals m minus 2, and j equals n minus 2, right? So what we do is that then we'll have long result equals 0L. So what we do is that while I greater equal to 0 or j greater equal to 0, right? So we'll say if this j is smaller than 0, that means j already moved out of the range. Or this is I is greater equal to 0, and horizontal I is greater than vertical j, right? So in this case, we are going to perform an horizontal cut, right? Because horizontal is greater. And we can also have an horizontal piece, right? Horizontal count. At the beginning, this one equals to 1. In the vertical count, this one equals to 1, right? You can also use if you don't want to use this one, right? One more, those kind of more parameter should not hurt. You can still, for example, use the actually this h counts equals m minus 2, m minus 2 minus I plus 1, right? So that is m minus I minus 1, right? So if you don't use these two variables, it is fine, right? But how actually it doesn't hurt. Then we're going to have a result should plus equal to 1L multiplied by horizontal I, and multiplied by count. And we'll have a horizontal count should increase by 1, right? And then we move this I pointer, right? And else we are going to have a result plus equal to 1L multiplied by VG multiplied by H count. And we'll have V count should increase by 1, right? And J management. In the end, we just return result. Doing like this, the time complexity, there is a sort, right? So this is m multiplied by m log n, and m log m, and this is n log n, right? And this is O m plus n, right? So that is O m log m plus n log n, right? And plus m plus n, right? We are thinking about this question. That is, we'll say, they have those kind of range. Horizontal costs and vertical costs are in smaller or equal to 10 to the power 3, right? So we know for this kind of range, right? We'll see it is smaller to this kind of mn order. So we thinking about for this question, is that we can use some kind of bucket sorting to do the question. That is, we use two buckets. One, and each bucket is 1001 for the horizontal and the vertical. And the things that we have just approved for this kind of VI, HI or VG, right? If the cost is the same, that means we do horizontal cost or vertical cost. The order does not matter, right? Both will at the same incremental delta. So what we do is that we have the buckets, right? And every time, so this is from 0 to 1000, include 1000, right? So every time we now we just have the pointer from 1000 move to 0, right? So that means this is at cost 1000. If there is let's count how many horizontal I. For example, there is 500. How many horizontal I is in 500, right? For example, there are 20. Then our results will just have this kind of counts, right? Multiple by vertical parts and add to our result, right? And also, if there are, for example, 10 and horizontal costs at 500, right? So we just add 500 multiplied by 10, then multiplied by this kind of parts, right? So every time we move this kind of pointer, right? We calculate how many parts. For the horizontal cut, we cut how many vertical parts already, right? And every time we move this kind of, we also count how many horizontal parts we already have on the right. So so that we use a 1000 array, right, to do something like a linear operation, right? So we use a bucket to convert to simplify the sorting. So let's use a bucket approach as well for this, right? So we know we need to have two buckets. One is for the horizontal cuts, and another is for the vertical cuts, right? So both will have 1001, right? Size new 1001. And the reason we do this is we'll see this kind of 10 to the power 3 is much smaller than m and n, right? So we can tolerate small space complexity, sacrifice the space complexity to have linear operation, right? And we'll also have vertical counts equals new int 1001. So what we do is that for int let's still use this. Say in h, so we'll have h counts c plus, right? And we'll see for int c in v, right? So we'll have v counts C plus plus. So we have two buckets, right? So we are going to have this is the counts for those kind of cuts, right? And let's call H buckets should be bucket, H bucket, V bucket, right? May more make sense. So then we're going to have, for example, int H count equal initially as 1, right? And V count initially as 1, right? And we are going to have a long result equals 0L. So what we do is that for int I equals 1000, I I greater equal to 0, right? I minus minus. Of course, the cost 0, we don't need to add it. Actually, then greater or greater equal does not affect us, right? So we'll have result plus equal to 1L multiplied by I, multiplied by V count, multiplied by H bucket. I, right? So we'll have H count should plus equal to H bucket I, right? And then we'll have result just plus equal to 1L multiplied by J, multiplied by I, right? Still multiplied by I, multiplied by V H count, right? Multiplied by V bucket I. So we'll have V count should plus equal to V bucket. Right, right. But for this one in line 14 to 17, right? The order does not matter, right? Because we know for the same just we discussed the same cost. If the vertical and the horizontal have same cost, which one take place earlier does not affect the result. So in the end, we just return result, right? Cool. Being like this approach, the time complexity will be O(m) multiplied by n, and the space will be 1001, right? Well, let's write Python code for this as well. So we'll say we'll have H bucket, V bucket equals first will be this one multiplied by 1001, right? And this one also multiplied by 1001, right? And for H in, let's still change this one to be H, right? This one change to be for C in H. We'll have H buckets and C should plus equal to 1, right? So we'll see for C in V, we should have V buckets. Okay, plus equal to, and we have each part in H counts in the V counts. Initially, they set as 1 and 1, right? So for I in range should be from 1000 to -1, right? Or 0. Both should be fine, right? Because the cost 0, it will not add to total cost. So if we put the 0 to here, it is fine, right? But we have the buckets from 0 to 1001, right? So to not make a confusion, we use -1 here. So we'll have, let's have a result, okay? Result equals 0. And our result should be plus equal to I multiplied by V counts. V count multiplied by H bucket. I, right. And then we'll have H counts. H count should plus equal to H bucket. Buckets I, right. And we'll also have result should plus equal to I multiplied by horizontal count and multiplied by vertical buckets. Right. And we'll see how V counts should plus equal to V bucket. In the end, we just return result. Okay, so there is another question that is the minimum cost for cutting cake 1. It is similar, but the time the M and N range is very small, right? For that one, we can do like DFS plus memo or a lot of approaches to do that. But DFS plus memo, for this question, it will be TLE, because we should have that for this kind of range, we should have linear or M log M or N log in this kind of time complexity.